good morning or good evening, depending on when this video finds you. We're picking up and starting our third video for this chapter. This was our first one, Ecology, Work With What You Got, slides 1 through 5, 13 minutes of it. And then we moved on to our second video. This is Ecology, Work With What You Got, slides 6 through 9. This is going to be Ecology, Work With What You Got, slides 11 and beyond. We'll know by the time we get to the end, okay? Stay with me. Try to keep up, and good luck. Don't forget always to pause it whenever you need help. All right, a quick review is our ecology problems, the purpose of this whole chapter. Problem number 1 was, how does environment influence survival? Today, we're going to see what in the environment can influence our survival specific to these. So survival depends on limiting variables, a new type of variable. Survival in our environment, and for any organism, depends on range of tolerance. We're going to study this word. And surviving our environment depends on succession. What are any of these? Well, we're going to study it. Don't worry, okay? So we'll practice all of these new definitions, this vocab, so we can speak better when learning about ecology, and we can speak better when we try to answer later how the environment influences survival. Lastly, if this video is long enough, we will then start talking about HEL, or HEL. It's a special activity where we're going to focus on a special kind of environmental issue, climate change. And let's not forget we have problem number 2. What do we need to know about our environment, Burbank and beyond? And our Ecolicious experiment is helping with that, as well as we're going to look at climate change and what we need to know about our environment locally, or California, or the planet. What do we need to know about climate change, all right? So let's keep moving forward. First slide is slide 12. In slide 12, we have our definition. So as always, pause this recording and then copy down this definition, limiting variable. So you, in your notebook, you would write slide 12, limiting variable equals, and here's some examples. All right, examples of limiting variables are how much food you have. This might be not so important to us. Most people, we have plenty of food. In fact, we have so much food, we gain weight. All right, according to obesityactionscotland.org, 2 in 3 adults are overweight or obese. 2 in 3. That's that's over 60%. We got plenty of food in our environment. But in nature, wildlife, plants, maybe they don't get enough food. But certainly humans generally, in developed countries like our own, majority are getting plenty of food. But it's still a limit. Another example is predators. Again, in our cities, predators are rare. Criminals who are violent, maybe you can consider predators, but mostly this is a wildlife issue where you have all the animals in nature, things trying to eat them. And then you have temperature. We're going to be talking about climate change soon, but in general, cities are much warmer than the surrounding nature. So we live in very warm places when we live in cities. And that definitely could be a limiting variable. Temperature is indeed a limiting variable. Look, you can see in nature, when sunlight comes into our atmosphere, you can see the solar radiation in nature tends to, as it says, bounce around and gets often sent back into space. But when the sun heats up and shoots radiation into the cities, it says the buildings trap the solar energy. All the pavement, all the buildings, all the development we do in our cities, heat gets trapped in there, and that can cause what we call a limiting variable. Let's study that a little more. So whether it's living things like predators, whether it's food availability or temperature, any biotic or abiotic, remember living or non-living, variable in an environment that makes it hard to survive and reproduce. So anything that's a threat, really. So anything that affects our survival and makes surviving more difficult, you can call a limiting variable because it limits our survival. All right, so hopefully you have that definition down already, but remember, in your notebook, you should write slide 12 and then copy the definition. Now let's move on to the brainstorm web. Just like you see right here, I would like you to take half a page in your notebook, so half a page, and make this just like you see it. It says limiting variables for school success. So I'd like you to come up with 3 variables or examples of 3 limiting variables for school that makes it hard to survive in school or hard to succeed in school. Here's an example. Getting enough sleep. There's an example. Because sleep does, in fact, affect how you perform. And you need it to study well. You need it to stay awake in class. So it's a limiting variable. If you don't get enough sleep, your brain doesn't work well enough. You may not do well in class. You may get a low grade. And then maybe you're bummed out. Can you think of some more? Don't use mine. Come up with your own, please. Come up with 3 different limiting variables that you think make school success or survival hard. Things at school that make it difficult to succeed. Whatever you do, do not say these YouTube videos. How dare you? All right. We have another way to look at limiting variables because we want to practice some more. So this is slide 13. So let's write slide 13 in your notebook and then copy down this information. It says limiting variables cause survival issues, but a species can tolerate a range of environmental stress. And so it basically means even though there's things that can make survival hard, we can kind of adapt and tolerate or handle, we can do well with certain things that are bad in the environment. Like if we don't get enough water, it's bad, but we can get small amounts of water, we should survive. We may not get all the food we want in our environment, but if we get a little, we should survive, right? So it's a range. Let's look at an example for temperature. So what does it mean, a range of environmental stress? So where I put range of environmental stress, let's look at the temperature and what that means. Here is a range of temperatures. It starts at 0 degrees and it ends at maybe 40 degrees Celsius. So very cold here, all the way to warm. So the temperature ranges from cold all the way to warm as it goes from 0 degrees and ranges all the way up to 40 degrees. In this example, you can see that plants are being experimented on, and you can see how well plants do at different temperatures. So plants do differently over a range of temperatures. This plant is surviving. So is these in the middle, where it's warmer. And this plant is surviving where it's really warm at 36 degrees. However, even though they're all surviving, you can see that these are doing much well. Very good, right? This is a perfect temperature. So even though this isn't a perfect temperature, even though this is, they're all surviving, so they can tolerate a range. However, these plants are more likely to die. These plants are less likely to survive and thrive and be happy, right? Because they're not getting exactly what they like. So this is limiting how fast they grow. This is limiting their chance at survival, but they are tolerating it a little. That's example B. Example A shows you a range of different amounts of gas or oxygen dissolved in water. If you have too little oxygen in water, fish can die. As it says too low for fish populations. Or you can have high levels of oxygen in the water. So the range from no oxygen in the water to lots of oxygen in the water decides if fish can survive or if they're going to die here, or if they get plenty of air and survive here. This says abundant fish population. So at this range, really high levels of oxygen are really good for fish to survive, right? Now, here's the task. Hopefully you've already wrote slide 13. Hopefully you've already wrote the definition here. Now it says in your journal, pick one, option A or B, and explain how it shows limiting variables. So look at this data here, or look at this data here, and say A or B shows a limiting variable by, and and explain how one of these demonstrates a limiting variable. Here you go. It says in your journal, it says A or B, choose one, shows blank variable. What's the kind of variable we're looking at, right? So fill in the blank properly. Shows blank variable because at blank range. So choose a range here or a range in B. And just describe what that value is, whether it's a temperature or an amount of oxygen. To show that survival is, are we talking about the range that makes survival easy or difficult? All right, and that's it. So you can use this sentence to help you. All right, slide 14 here. So in your notebook, write slide 14. And don't worry about this definition. You already did it earlier. I want you to focus on this box. So in your notebook, write slide 14, and then we're going to create a hypothesis for our Ecolicious experiment. So here's a sentence frame for you if you want to use it. But the idea is that you're going to create a hypothesis of what you expect is going to happen when you put the independent variable in your ecocups. So whatever your independent variable is, we generally think it's going to be bad for survival. Thus, your independent variable is also a limiting variable. So we're learning about a new variable, right? Limiting, anything that causes survival issues. Most of what you're putting in the cups you do expect will make survival hard. The question is, do you really think you're going to be surprised by the results, or you're going to have a straightforward one? In your notebook, this is what I'd like you to write. Hypothesis. So you copy this down right here. And write, I'm confident that blank, whatever your independent variable is, will function as a blank variable. So this would be limiting. And you're confident that, in my example, let's say drought. I'll just say drought. And then it's an independent variable, right? In my example, your independent variable will be different, but it will function as a limiting variable by causing what? So what do you think the result will be? So when you add your independent variable, you think it'll function as a what, right? Once you have this hypothesis created, you're going to work with your team at some point and add it right in here. You see this? We have a new thing in our designing our ecocups. It says your hypothesis for the effect of your independent variable. So for each of your teams, whichever period you are, period 2, 3, 4, 5, 6, whatever, every team is going to use what you're thinking, potentially, to decide on an official hypothesis for what you think is going to be the effect of your independent variable, what it's going to cause, right? And you're going to need your reflector when you guys get together to make sure everyone agrees for what you type in here, or what the recorder types, right? All right, good luck. All right, this is slide 15 in your notebook. Please write slide 15. And then here's a very brief definition for range of tolerance. Remember, tolerance are the things you tolerate in life. We may not like people bullying us, but we can tolerate it. We can get by. We may not like not eating all the time, but we can tolerate it. Range of tolerance. It says a range of conditions, so things in the environment, conditions, an organism can survive or tolerate. So it's the stuff you can handle in your environment without dying. So whatever doesn't kill you is something you tolerate. All right, we have some questions here. 1, 2, 3. I'm going to try to go over them and help you answer them, and then that'll be the end of our slides for this third video. Okay. So in general, we have our data right here. So to answer these 3 questions in your notebook, we need to look at the data table. It says first, it says there's a winter storm and the temperature goes down all the way to 27 degrees Fahrenheit. Which plants might die? So which plants are going to be out of their range of tolerance? Because this temperature could kill them. Let's see. All right, according to this chart, it says coldest tolerated for salvia is 32 degrees. If the temperature goes below 32, salvia will die. If the temperature goes below 32, sunflowers will die. If the temperature goes below 17, sequoia trees will die. And if it goes below 0 degrees, the monkey flower will die. 2 of these species will die if the temperature goes down to 27. Which of these species will die as a result of the temperature dropping? So the temperature went outside their range of tolerance. They couldn't handle it. All right, number 2, it says all the pine trees have been cut down in a park. So it's an example, right? It's a scenario. So pretend that all the pine trees in a park in our city of Burbank have been cut down. Which plants will do better within their range of tolerance? Which will do worse out of their range of tolerance? And how many will do the same? They'll be fine. So you want to focus on ideal sunlight. So which ones need shade? With the trees cut down, there's going to be less shade. Salvia loves shade. It needs it. Sunflowers love sun. They're happy if there's less shade. Sequoia is okay with a little bit of sun, and monkey flower is okay with a little bit of sun. Which plant here will do better now that there's more sun in the park? So basically, which now is in their range of tolerance for sunlight, and which one is out of their range of tolerance? Which one will die? And that'll be the answer to number 2. Lastly, if there's a drought for 2 years, which plant would most likely survive a drought? So which plant can handle the least amount of rain? It's all about range of tolerance. Which one can tolerate the least amount of rain?